Push the button, recording, and now we are live. Everybody's seeing us in the forest, okay, up on the trees, in the burrows, underwater, the beavers and the apes and the other creatures. They're all watching our organic show. That sounds like something that we should call our lectures, the organic show. Okay, no more jokes, no more bad, terrible jokes and bore you guys. I'm going to switch to the other camera, the webcam, and let's get started. Okay, this is from my 129A, the organic lab. This is where I have traumatic feeling. I feel I go through like guilt and sinfulness. That's a new word. It's going to go into the dictionary. I feel extremely guilty when I teach the organic lab because you can't teach organic lab this way. So anyway, I've decided that for their lab, I'm going to go into my research lab and probably harass one of my research students and start doing some demos. That might be a little closer to the real thing. So you don't have to know this. We were talking about safety. We're talking about making something useful, like Tylenol. This is what Tylenol looks like. You probably don't know exactly how these structures look, but then this is Tylenol, and I was just talking from a philosophical point of view that you mix this guy and this guy to make Tylenol, which is a good molecule. It's supposed to be therapeutic, reduce inflammation, reduce fever, reduce pain, reduce headache, all that stuff. But then it's made from compounds that can be a little sketchy, okay? Toxic, maybe hazardous. So we're just talking about safety. I was giving them a demo that these are the gloves that you're supposed to be wearing. You're supposed to be wearing safety glasses. And then at this time, you are also supposed to wear the mask to prevent others getting sick from you if I'm asymptomatic or whatever. So we're just talking about that. So just kind of breaking down all the compounds, hexane, cyclohexene, that's a double bond, a compound with two double bonds. That's same molecule, hexane. So when you draw a stick, we are not lazy, okay? Organic chemists are not lazy, I promise. We are just trying to be efficient, okay? So this means there is a carbon. So that at end of a stick is a carbon. That's another carbon. So carbon, 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 carbon. That's a hydrocarbon. We talked about methane. So this is hexane, 6 carbons, okay? See, this is something that we can talk about and you guys can understand. So I'll teach you how to use this stick diagram to designate molecules. So usually this means every end and every bend, there is a carbon. C, 6 carbons. Each carbon, how many arms does each carbon have? We have already learned it. Who remembers? 1, 2, 3, 4, or 5. How many tentacles does each carbon have? You can give me a finger gesture. I'm only seeing like half of the class right now on the first screen. How many arms, how many things can carbon attach with? We have done some simple, like some, what do you call the, we haven't really done that. We have only gone through the syllabus, right? Yeah, we haven't done that. So I'm confused. Anyway, carbon can connect with 4 other things. So basically carbon has 4 tentacles as an element. So there are hydrogens here, there are hydrogens here. So this is how we describe a big molecule without drawing every time carbon and hydrogen and chlorine, stuff like that. So we try to reduce our pain by using some symbols. So this is what we were doing. Then we talked about this guy is a benzene molecule. It used to be used in the paint industry as a thinner. And it turned out that this is a dangerous compound. Benzene, this is hexagonal compound with 3 double bonds. It's a dangerous compound because it causes cancer. It's called a carcinogen, okay? many years ago, when this information was not known to human beings or scientists, people who were in the paint industry, they would use benzene and probably touch them. A lot of people still do not wear gloves when they're working around the house, they're painting or something. I mean, I've seen mechanics all, with engine oil and all other stuff all over their hands and face sometimes. So many painters who dealt with benzene and doused themselves with benzene, it's a liquid, they died from cancer. So that's dangerous. This molecule, you can see that benzene with a OH group. OH group makes a molecule, like we call them alcohols. So this is CH3CH2OH. Some of you know that it's ethanol, okay? That's ethanol. This is kind of like ethanol, but this alcohol is on a different kind of a molecule, on a benzene ring. This guy is called phenol. It has a very pungent smell. Sometimes it's also called, there is a nickname for it, I'm trying to remember, carbolic acid, C-A-R-B-O-L-I-C, carbolic acid. I grew up in a town back in India. That township was built by taking down forest and to build a township for a steel plant, where my father used to work as a senior chemist in their research and development section. So we lived where there used to be a forest. So we were growing up with all kinds of creatures. I hear that when I was a kid, there were fox, rabbits. There were still like lemur monkeys. They would come and destroy our vegetation, whatever our family was trying to grow in their backyard, including mangoes and guavas and stuff like that. And we had snakes, cobras, and carbolic acid. We used to sprinkle carbolic acid around the perimeter of our house to ward away the snakes. Apparently, they don't like the snake. It's kind of like an insect repellent and small rodent and other creature repellent. Nobody likes the smell of carbolic acid. So this is also dangerous. It's pretty toxic. This guy, benzene ring with an amine, NH2 group, that's called aniline. It's also not good for your health. But the funny part is, this is the funny part. This molecule has a benzene ring, carbon, 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 6 carbons in that ring, and double bonds in between. Okay, there is a OH group, there is an NH2 group. Like this would have been phenol or carbolic acid, the snake repellent. This is aniline, it's kind of like an amine. But this particular molecule has both those groups. And when you react it with something like this, I won't get into the details and bore you because you're not prepared yet. Okay? When you react them together, what happens is part of this guy, which comes from acetic acid, you know what acetic acid is. Acetic acid is vinegar, the sour tasting material that's present in the chips. Once you tear open a bag of chips and start eating the chips, and the sourness, that pretty attractive and addictive sour taste that comes from acetic acid. Carbon, 3 hydrogens here, double bonded oxygen, 1 oxygen, and H. This is called acetic acid. When you take 2 acetic acids, remove a molecule of water, you get this guy, it's called acetic anhydride. Let's not worry about that right now. So when you take this guy with this guy and heat them up, you get this molecule where the hydroxy group is retained, the main hexagonal benzene ring is retained. Down here, it used to be NH2, just an amine. They're called amines. Now, one of the hydrogens is gone, and part of this acetic anhydride, this part, the black carbon, the invisible hydrogens, the carbon and the double bonded oxygen, that whole piece gets transferred onto that nitrogen and you get a brand new compound. What is this guy? Para-acetaminophen, the ingredient of Tylenol. This is therapeutic. It reduces inflammation in your body. It gets into your brain, reduces the inflammation in your brain, gives you relief from headache. it takes down your fever, and overall, it's actually a good thing because it overall reduces the inflammation of the body. So this is a good guy, but the good guy is made from bad people. So the whole idea of our discussion yesterday in 129A, the organic lab, was that whether you are dealing with good people or bad people, or you're converting bad people into good people, you need to be very careful. You need to wear gloves, don't touch any chemicals. You need to wear safety glasses so that nothing gets into your eyes. And you need to wear lab coat, which is right here. You know, I hang it from my little door thingy. So you need to be very careful. So this is kind of how I thought I would break ice and kind of start talking about safety in our otherwise virtual organic lab. So that's pretty much what we're discussing. But I think it's a good way to break ice for you guys too. Like you are probably not following like what these compounds mean and all that stuff, but then now it's going to make more sense. I'm going to erase the board. I just realized that I have only had one lecture with you guys, and we haven't really talked about anything, any molecules. So that happens a lot, especially when you are getting older. When I'm teaching two of the same classes, sometimes it can be a little confusing. So if I'm completely off, don't hesitate to shut me up. Like, Shantanu or Dr. Maitra, do you know this is really not making sense? We are the Tuesday, Thursday class, not the Monday, Wednesday, Friday class. So then I'll probably wake up. Okay, so let's talk about some chemistry now. And I'm going to break it down. And so I'm going to break it down, and I'm going to make it start from scratch, literally from scratch. And my wife was asking me not to use one of the colors. I don't know which color she was mentioning. I think she said the red is hard to see. Now, so what I was going to say is that I'm going to start talking about chemistry, organic chemistry, elements and molecules from the scratch, from very bottom-up approach. Okay, I'm probably going to be using some metaphors. I'm going to use some like games like Legos. If you're on top of organic chemistry, if you have already read the chapters and if you're already pretty aware of it, okay, don't feel insulted. I'm not trying to insult you or undermine your knowledge or wisdom. For the majority of the class, you guys are coming with all kinds of backgrounds, which is pretty fun for me. I mean, I really enjoy teaching Chem8 because my job is to get you guys excited about organic chemistry and see the value of the learning, the wisdom that's in this course, and how you can take it with you in the rest of your life and still be useful, and maybe remember a few things here and there from this class, and feel good about it and make use of it. If some of you can do that, then I have every reason to breathe the wonderfully clean air in the Central Valley, and especially on Fresno State campus. Okay, so anything that you see around, the board, the pens, my shirt, my hair, skin, teeth, all the biochemical processes that are happening inside a living system, not an unliving system, there is something to do with chemistry, okay? Organic chemistry primarily deals with carbon, hydrogen, nitrogen, oxygen, such things that are found in nature, okay? A couple of other things. You might find that the board is going out of focus sometimes, because what's happening is I am standing here in between the camera and the board. So when I'm standing right in front of the camera is focusing on me and putting the board off focus, defocused. So whenever I move away from the board, you will find that the board is back in focus. And remember that I will also take a still photograph of the board and post it on Canvas. So no need to worry about that. Sometimes if you are not having a good view of the board and it's blurry because it's out of focus, just let me know. I'll hide in the corner, then you can get a better view of it. I'll probably remember to do that. Okay, I'm going to check that link later on, and I'll check it out. I haven't found a good link or a resource for the solution manual or the study guide for cheaper price. If you guys find something, go for it. If you are comfortable with a soft copy, go for it. If you're comfortable with a soft copy, some of us are still pretty old-fashioned and need like a real book. I'm okay with soft copies, especially if it is significantly cheaper. I couldn't find anything really useful. So yeah, any help in the chat group, that's extremely nice of you. I strongly recommend that you do that. But just make sure that you're buying the right solution manual from the right book. Just don't buy anything random, like don't waste your money and you cannot return it. There are all kinds. I'm having some problems with something that I recently bought from eBay, and the seller is really mistreating me right now. Okay. So anything that you see has chemicals. Our body has all kinds of chemicals, including some metals too. Like hemoglobin has iron. Some other proteins have zinc or copper. We have manganese. We have other chemicals, sodium, magnesium, calcium, potassium. All kinds of things are present in our living system. Okay, some halogens, chlorine, fluorine, bromine, iodine, some halogens are also present in our living system, in our body. Okay, primarily organic chemistry deals with these guys. Okay, if I will just do an experiment, I'll get out of the view and make sure that the screen is focused properly. Does it look good? Can you read the letters clearly? You can give me some thumbs up maybe on the screen. I'm looking at the screen right now. Is it good or is it bad? Maybe you can unmute yourself. Okay, good. It sounds good. Okay. So the elements, the good news is that this is an organic class. If it were an inorganic class, we'll have to deal with more than hydrogen, carbon, oxygen, nitrogen, boron, some of the halogens. We'll have to deal with many other elements, and that gets pretty complex and painful. Okay, I'm not an inorganic chemist. I have more respect for inorganic chemistry, and they're just all over the place, and they have to dig deep all over the place, and it's not an easy task. So they're usually they're working much harder, and their wisdom is deeper and wider, than us. Okay, so we primarily deal with these elements. We deal with hydrogen, and it's usually written as H, uppercase H. We deal with hydrogen. We sometimes deal with helium to prove a point. Okay. We deal with boron. Let me put a different color for boron. I used to think that I can only hold 4 pens, but I'm kind of adopting to holding more than 4 pens. Boron. This is really bad. You can't see it. Let's use brown. You may not see the color, but when you see the still picture, it'll probably make more sense. So I'm going to continue to use it unless it's not legible, unless you can't really see it. I'm assuming that you can still read it. Boron, B. Then we have famous carbon. Carbon is written as uppercase C. Then we have nitrogen, uppercase N. Then we have, I'm going to use red. Then we have oxygen, O. And then we have, shall I talk about it now or shall I wait? Let's talk about it. Purple. Okay, how many pens am I holding? 1, 2, 3, 4, 5, 6. I'm really proud of myself. Fluorine. Fluorine is F. Okay, so these are some of the elements that unfortunately or fortunately we will be dealing with. I don't need this guy. I don't need, I think I can handle 5. So hydrogen, helium, boron, carbon, nitrogen, oxygen, fluorine will be some elements that we will be dealing with quite regularly through the semester. Okay, so get used to it. So these are the elements. What does element mean? What is the difference between element and a molecule, or an element or atom and a molecule or a compound? So let me write it down. Element, atom, and I'm going to write down molecule or compound. It's not in the same order. Okay. Element or atom versus molecule or compound. Anybody wants to pitch in? Unmute yourself and say, like, what do you think about the difference between the two? What do you guys think? Are these guys elements, or are these guys atoms, or are these guys molecules?
Elements.
Hydrogen, helium, boron, carbon, nitrogen, oxygen, fluorine. I'll shut up. It's very difficult, but I'll try. What do you guys think?
Elements.
They're elements. Okay. So if I write something like this, I don't want to trip on my boot. If I write something like H2 or H2O or NH3, or what's the color of boron? Brown. Sorry, it's not really very well visible. BH3 or CH4 or let's use this this guy, the fluorine guy, or F with 1H, or let's mix. You know what? Let's not mix here. I'll ask you guys to make a molecule with 3 elements. Okay. I already dropped a hint. Hopefully you didn't hear it. Okay. That's my wishful thinking. Okay. So these guys and these guys. Okay. One answer was these guys are elements or atoms. And so basically these guys are elements or atoms. Then what are these? What are these on the left side of the board? H2, H2O, NH3, BH3, CH4, HF, another one, interesting, F2, or yeah, let's keep it simple right now. I'm trying to think like if there is any other combination that can happen. There is actually an interesting combination that can happen. B, one boron, and
All the way behind.
3. Okay, what are those? Are those elements? What are those? What do you guys think?
The molecules / compounds.
They're molecules / compounds. Very good. V. V as in Victor, V as in Victory, V as in Vincent. V as in Vincent. Okay. So these guys are molecules. Very good. Perfect. And again, I'm not undermining your knowledge. You probably already know all this stuff. So just hang in there. It's better to build from the bottom up because some of you may be coming with different like non-chemistry backgrounds. I just want to make sure that at the end of today's class, your anxiety level drops, your blood pressure drops, not to an alarming level. That can be bad too. I'm not saying that you lose all your energy, but you just don't, you feel good about this class and you get motivated and excited. All of you should be shooting for an A, and then we'll see how it goes. So these are molecules. So, you know, sometimes when we describe an interesting person or like a crazy guy or a super nice guy or someone with some unique properties that you cannot find in the society, I've seen my parents doing that. Oh, what an element. My mother used to say, probably to describe a crazy person, like, oh, I went for shopping and this shopkeeper would not, you know, something. I mean, you know, I don't know. I mean, he was trying to shove some bad vegetables to me, and what an element. My dad would say someone, you know, like a really interesting person in his company, in the steel plant, very intelligent, never seen anyone like that. My dad would say, what an element. Okay, what does element mean? So let's say you find a material, you find a rock that's made from a bunch of these molecules, right? You find a rock that has everything. It's a meteor. A meteor, there was meteor shower, and you saw a meteor coming through the atmosphere with like a little burning, like a fiery rocket, and it landed. There was still something left, and you go to your laboratory sounds so weird, right? Lab, and you analyze them and you find a whole bunch of them, right? And then you are like, okay, I found 1, 2, 3, 4, 5, 6, 7, 8. I found 8 molecules or compounds in the rock that came from outer world, you know, not from Earth. And then what do you do? Then what do you do, and how do you find an element? So the property of hydrogen gas, the property of water, property of NH3, property of HF, property of fluorine gas, property of methane. It's a hydrocarbon, CH, hydrocarbon. We will discuss that in details. I'm just kind of introducing you, kind of breaking ice right now. Boron, this guy is called not boring, boron, B-O-R-A-N-E. One boron with 3 hydrogens, that's boron. And this is trifluoroboron. It's called BF3. That's another compound. So you have found 8 compounds in that meteor that hit Earth, and you happen to be there, and you picked it up after it cooled down, and you're like, wow, man, this is like a gold that I'm holding in my hand, because you know somebody's probably going to pay me a lot of money to get it because it came from outside. And you analyze it and you found those 8 compounds. As a chemist, what makes sense to do at that time, because you're trying to figure out like what's in there, right? So what would you do? And it's a mixture of 8 things. I'm going to drop a hint. This is what we're going to be teaching our organic lab students as one of the techniques. So you have a mixture of 8 things. What do you think will be a logical step for a chemist to do as a next step? Unmute and say something, even though you think that you have no idea what I'm talking about. Usually that's what life is all about. Usually we don't know what we're talking about. So you have a mixture of 8 compounds. What would you do if you and I are working in a research lab? Your job is to figure out what they are and what's in them. I'll give you an example. If your younger cousin or your nephew or niece was in charge of your kitchen because you were not there and somebody had to take care of your apartment or your house and nobody was there, and they basically ruled your house for like 2 weeks, then you come back and you find in your pantry that they all look pretty good, but you realize that something looks kind of fishy. The bottle that's supposed to have salt, it doesn't seem to be having only salt. There is something else in there, because when you put that salt in your chili, it tastes weird. Then your mom says, or your partner or your dad or your son or daughter or somebody else says, or your friend says, something is fishy about this salt. It's not just salt. Then you realize that something else is mixed in it, and it could be sugar, it could be something else. Another bottle you're supposed to have, let's say, like the mineral salt, and it looks different colored, like there are brown or reddish specks mixed with some white specks, and the white specks look different from each other. And you're trying to figure out, you're trying to be a chemist in your kitchen. What would you do to this inadvertently, or mistakes, or somebody, your niece was pulling a prank on you and she deliberately mixed up your pantry with different things. Maybe somebody was really trying to piss you off, okay? They poured some sugar in the salt, and they poured some black pepper in the salt, and then they put some others, the ground spices, together, and they really like ransacked your kitchen pantry. So what would you do to figure out, if it is worth, if you think that they're like saffron, extremely expensive, what would you do to those mixtures? It's an S word that I'm looking forward to hearing from you.
Separate them.
Separate them, right? You separate them. So you separate H2 from H2O from all of them, okay? So now you get to the bottom of the composition of that rock that came from outer world and hit the surface of Earth, and you happen to grab that. So now you know from analysis, you do all kinds of analysis, GC, gas chromatography, LC, liquid chromatography, high pressure liquid chromatography, it's called HPLC. You may have heard the word. If you have worked as an intern or an assistant in an analytical lab, you probably have come across the word HPLC, LC-MS. MS stands for mass spectroscopy. You can see how heavy the molecule is. So you do all of that stuff. You do infrared spectroscopy, you do NMR spectroscopy, nuclear magnetic resonance spectroscopy. Unfortunately, we don't teach those things in Chem 8, but they're pretty cool. NMR and MRI, magnetic resonance imaging, that's done in the hospitals, they're identical. You look the magnetic property of a nucleus, not the electrons. Usually we deal with electrons. This entire course, all the lectures, all the learnings, all the wisdom that's going to come from my brain to your brains will be dealing with electrons primarily, nothing to do with the nucleus. But MRI, magnetic resonance imaging, and NMR in the chemistry science area, nuclear magnetic resonance, deals with the nucleus. So we won't talk about that. So let's say we do all of that and we figure out that this dude is H2. We have something called H2O. That's the empirical formula or the molecular formula of the different element, not right, wrong, I just misspoke. Not elements, different compounds or molecules found in that meteor, right? 8 different things. Let's say 1, 2, 3, 4, 5, 6, 7, and 8, right? So when you pick up one, let's say you pick up the fluorine or HF or CH4 or BH3 or BF3 or BH3 or H2 or H2 or NH3, they all have their distinct properties, right? Your hair made out of specific proteins has specific property. Your skin has all kinds of compounds. Through your veins and arteries, blood is flowing and it's carrying all kinds of compounds, including things like cholesterol. Cholesterol is being carried like a ship is floating, like not ship, wrong, like a submarine, submerged in the river or the ocean and kind of flowing, moving from one place to another. Cholesterol and other compounds are kind of like that. Someday, when you guys have a better base, you understand more chemistry from this course, we will talk about cholesterol and some like medicinally relevant items, and I think it's fascinating. I was extremely bored when in India many years ago when I was the receiving end of general chemistry, like Chem 1A, 1B, or 3A or 3B. I did not like it. Honestly, it's an honest confession. I hated chemistry. I never thought I would become a chemist. My dream was to become a mechanical engineer, and I wrote in that Google Sheet, like I wanted to design motorcycles. I'm still fascinated by motorcycles, okay? I ended up becoming a chemist. I started liking chemistry when I started looking at these molecules. You know why? Because you can design some specific molecules like that little guy in Tylenol, right? I was actually showing the tablet of Tylenol to my students in the organic lab yesterday, and I said, this is chemistry. So when you start looking at a medicine or like a pill or a capsule or syrup or something, you will probably get a little better kick out of the structure of it. And maybe there will be some curiosity now on your part to express, like, what does it look like? What is it made out of? How many carbons? Is there a ring? Is it aromatic? It's aromatic, but it's still therapeutic. It's not going to kill me. It's not going to cause cancer. So I think that's the appreciation that hopefully you will grow at the end of this class. And I will probably have these healthy distractions all the time. I'm easily distracted, okay? And talk about their like real life relevance. Like, what is a pest repellent? Why would it do that? How do they interact? How do these therapeutic compounds interact in our body? What do they do? Why is it helpful for reducing my pain? Things like that. We'll talk a little bit about that. I don't want to drive you guys completely crazy or insane, okay? But these are molecules, and each molecule or each compound has their own properties. When 2 fluorines are together, it has some property. When 2 hydrogens are together, it's got some other property. H2O has certain property that's completely different from the properties of H2. H2O is made out of hydrogen and oxygen. NH3 or ammonia is made out of hydrogens and nitrogens. Methane is a gas, is made out of hydrogens and carbon. 4 carbons, 4 hydrogens, 1 carbon. 2 hydrogens, 1 oxygen. 3 hydrogens, 1 nitrogen. 3 hydrogens, 1 boron. 1 hydrogen and 1 fluorine. So you can see that they are comfortable making compounds in different proportions. 2 of me and 1 of somebody. 1 of me and 1 of somebody else. So it's pretty interesting. It's pretty interesting, and we'll talk about that. I just want you guys to kind of understand like what's going on. And if it is sounding really boring and foolish, just bear with me. It's going to get complex through the weeks that are about to come. Okay. So each compound has its own property. Okay? So if you take a material, if you take lots and lots of, like a balloon full of methane gas, or what's a solid here? Everything is liquid or gas. Let's say the closest thing that comes to my mind is H2O. You take a drum full of water, okay? It's a compound. There are lots and lots of water molecules, okay? You kind of break it down. You take like a little bit of water from the drum into a container, like a small cup, okay? Like my coffee cup. It was gifted to me by a student who is a dental student right now in Arizona. It's from Massachusetts. You fill it up with water. Then you take a little bit of water in a small test tube, just a little, maybe 1 or 2 milliliters, melts. Then you break it down and break it down and break it down and break it down and break it down. You get to one molecule, just one little tiny molecule of water, okay? It's got its properties, right? So then you start breaking down further, and from there, from one molecule of water, you find one molecule of water. If you could break it down, it's not easy. If we could crack the code of breaking hydrogen, 2 hydrogens and 1 oxygen from water, then that would solve all our energy crisis. It's not easy. Okay? We get 2 hydrogen dots, 1 hydrogen, another hydrogen. Then we get, it's beginning to look like a face. Okay, that's looking like an alien face. 2 eyes, that's the eyebrow, and that's the nose, and that's the mouth. Okay, I have some problems up here. My mother should have taken me to a psychologist a long time ago. It's too late. I cannot be repaired anymore. Okay, so you break down a molecule. Molecule or compound, and you get bunch of elements. Right? So far, so good. So elements cannot be broken down anymore. If you break down an element, we will have to, unfortunately, study all of that business, like what's inside an element. You guys know the answer, so I'm not judging you. I'm not assuming that you guys don't know anything. You guys know it. I know that. Okay. So when you break down an element, you get further down and you find the subatomic elements or atoms. Okay. Something is growing on the left side of this alien head. Maybe that's how they go, like they have a parasite. Sounds creepy. Okay. That's an idea for a new horror alien movie. Okay. Hydrogens and oxygen, when you break them down, that's what we're going to be learning, most likely on Thursday. Today is Tuesday. I'm losing track of days because weekends don't feel like weekends anymore and weekdays don't feel like weekdays anymore. Every day is pretty much the same. So, so that's what happens. So elements have properties. Molecules have properties. I'm going to get out. I'm going to ask you a question. Do you think there is any correlation between the property of hydrogen as an element with the property of water as a molecule? Do you think there is a direct correlation? If you put 1 carbon with 4 hydrogens, you can predict their property because it's made out of carbon and hydrogen. It's going to behave a little bit like carbon and a little bit like hydrogen. Do you think there is a correlation, or it's kind of absurd? What do you guys think? Unmute and say something. If you think I'm crazy, you can say that too. I've learned to kind of grow my skin thicker. So is there a correlation between the properties of an element and properties of a molecule that is made out of the same element or different elements? So what do you think? What do you guys think? Any comments? Don't write in the chat. I'm not looking at the chat. I'm far from the chat. My screens, I can't see the screen. Yes or no? Don't give me a thumbs up because I can't see the other screen. It's kind of unfair because I'm only looking at the first screen.
Yes.
Yes?
Maybe, I'm not sure.
How many of you are there right now? Let's see. 41, 40, 43. That's pretty good. That's very good. That makes me feel good about my breathing oxygen. Okay. So there is some correlation, right? If you put carbon and hydrogen, you get some kind of a compound that's got some properties. You mix hydrogen and fluorine, you get a different compound. You mix hydrogen and nitrogen, you get a different compound. Hydrogen and oxygen, you get a different compound. However, the property of, you guys know the property of hydrogen gas, right? It's a gas. Okay, give me, I already said one property. Give me 3 physical properties of hydrogen gas. What do you know about hydrogen gas? You can unmute and just say one property. Is it a liquid or gas or solid?
Gas.
Speak louder, I can't hear.
Gas.
Unmute and speak so that we can all hear you. Is it a
It
gas,
is a gas.
or solid? One more time, sorry.
A gas?
It's a gas. Second bullet point, who knows about hydrogen? Any other property that makes hydrogen a special molecule? What about its density compared to air? Do you know what I'm talking about? Is it lighter than air, or is it heavier than air, or is it same dense as?
Lighter?
Sorry?
Lighter?
Lighter. So give me an example why hydrogen gas can be used for human benefit. You know that guy who didn't use hydrogen, he used helium. He tied a bunch of helium balloons to his lawn chair with a BB gun. You heard about that, right? The high-flying jets found a weird UFO, unidentified flying object. And when the pilots got close to that weird flying object, they found that there was this crazy dude sitting in a lawn chair tied with like whole bunch of balloons, and he was flying at like some ridiculously high altitude, and he was carrying a BB gun. His whole idea of descending was to start popping the balloons and losing altitude, and then they sent a couple of F-16 fighter jets to basically follow him. And what the hell he was up to? I mean, was he a terrorist from a different country? What was his original idea? He just wanted to fly using his lawn chair. So, you know, he didn't use helium, thank goodness, because when you pop a helium, he didn't use hydrogen, because if he was going to pop a balloon with a BB gun, you never know what could have happened, okay? He used helium, but then they both have the same properties of being lighter than air. Good, thank you. Third bullet point, I have already dropped a hint. What's the third bullet point about hydrogen gas? Something not fun. You guys know, come on. Hindenburg, that flying machine many years ago.
Flammable.
Sorry?
Flammable.
Flammable. Flammable, very good. You can Google Hindenburg and learn about all about that. I don't want to take up time. I already get distracted enough for my daily life. Okay, so flammable. I'm just thinking about another property that hydrogen has. I believe it's hydrogen also has, and helium probably has it too. Do you guys know that you can do something funny with one of these gases? Do you know what I'm talking about? You might have seen it in Big Bang Theory if you watch Big Bang Theory.
Changes your voice.
Sorry, your voice, yeah. If you breathe it in, it affects your vocal cord and you start sounding really funny. And I don't know how many of you have watched that particular episode on Big Bang Theory. You can give me a thumbs up if you have watched it. When they pulled a prank on Sheldon by passing helium into his office when he was supposed to have a very important telephone interview with a radio show host, Myra Plato, from the science guy, or someone, I don't remember exactly. There are so many episodes, and Sheldon started speaking really weird and funny, and his friends were basically laughing at his cost. So all these properties. Water. Earth wouldn't have been Earth without water. What time are we at? 1:24. Okay, I'm doing exceptionally good with my time management skills. I have zero time management skills. Our son is learning from me. And I got upset and I said, I should not get upset with our son because he was running late. And he said, oh, now they're going to say that Neil is coming on Neil time. I'm like, and he kind of looked at me like as if it was my fault. I'm like, why is it my fault? Like, just go and drive up north. Okay. Water has its own properties. Is it a liquid or gas or solid? In Greenland,
Solid.
it will probably be liquid, but you know what I'm talking about, right? It can stay in all three forms: liquid, solid, or gas, steam. In the sauna, you have steam of air, liquid. While we are talking about solid and liquid and gas, I'm going to ask you a question. I'm going to always push you, and we're going to always take leaps forward. Sometimes multiple leaps forward. I'm going to ask very unfair questions to you guys to see if you're thinking like a chemist. Thinking like a chemist is being organic chemists have to be very street smart. We cannot be very bookish and textbook oriented. Sometimes when you're working in the lab, you're changing your path and your course of actions all the time. Something gets screwed up and you have no idea. The book doesn't tell you what to do. You have to basically figure it out on a fraction of a moment very quickly to save that situation, save your compound, save your reaction, and be safe and not cause any disaster in the lab. So you have to be, so when some of my students in the organic lab will say, Dr. Maitra, I followed all the directions in the book and what you asked me to do, but look what I got. Like everybody is supposed to get like 100 to 500 milligrams, which is 0.1 to 0.5 grams of a white compound. And there was this guy in my graduate school when I was a TA, teaching assistant, many years ago. This gentleman would somehow manage to do something differently. And he was an elderly guy. He was in police for a long time. So he had some boldness in him. I'm trying to use a very gentle description of him. He was a nice guy, nice friendly guy, but he can be extremely arrogant and stubborn. So he would come up and say, Shantanu, he would call me Shantanu because he was almost as older than me. He was coming back to school after some time. He would say, everybody else got like half a gram of some white or dirty white solid. Why did I get this? And I look at Nick's flask and he had like 10 grams of some yellow garbage. And he would always blame it on me. He would say, Shantanu, I followed your rule, followed your procedure. I followed the book. I did everything the book said and everything you said, but I don't know what went wrong. So sometimes that can happen too. So the different compounds have different properties, even though one part of the compound can be same. So talking about water, water can stay in a solid form or a liquid form or a gaseous form. Ammonia can also stay in, okay, let me ask you, ammonia, before I'm getting distracted. I was supposed to talk about water, but we'll take a quick break from water. I'm going to ask you a question. Ammonia. Have you seen a bottle that says ammonia or something like ammonia in your household, in your house, in a certain part of your house where everybody has to, whether you're a Nobel laureate or you're a hobo, you have to visit? Where have you seen the word ammonia?
On the products.
Say that again, louder. I can't hear you. Maybe my volume is down.
Is it on the cleaning products?
Cleaning products in the bathroom. Have you guys accidentally smelled ammonia? Does it smell pungent, or does it smell sweet, or does it smell sour? What does it smell like? One adjective I used was pungent. Pungent means kind of like strong and, you know, hits you in the nose and kind of gets into your throat. Does it smell like that?
Yeah, that one.
Yeah, that one. Very good.
Kind of burns.
Somebody has smelled ammonia. Okay, a little bit of smelling ammonia. No, I should not say it because you guys will do something bad and I'm going to go to prison. So I don't want to go to prison yet. Okay, not that the time hasn't come yet. Okay, ammonia. This is a trick question. What do you guys think about the physical state of ammonia? Do you think it's a liquid or gas or solid? What do you guys think? So those of you who have seen the ammonia as a cleaning product in a glass bottle or in a plastic bottle, it's a liquid or solid? Do you sprinkle it on the bathroom floor or do you pour it?
Liquid.
Sorry?
The liquid.
It's a liquid. Okay. If I say,
Ammonia is a gas.
say that again. Who are you? What's your name?
Ammonia is a gas.
Catherine. It's a
Yeah.
gas. So
Yeah, it's a gas.
if it is a gas, how do you get it as a liquid in the bottle, as in the cleaning material?
Didn't you add a hydrogen?
You're thinking in the right direction, but not exactly. The ammonia is a gas. Right answer. Ammonia is a gas. So what you get as a cleaning solution that says ammonia is not exactly ammonia. Ammonia and something else. What's that something else? That something else is also there on that side in the list of 8 compounds we found in the meteorite, which is nonsense.
Water.
Tatiana, perfect, perfect. So what you get in the container is a mixture of number 2 and number 3. That sounds weird. Water and ammonia. And does anybody remember from your general chemistry, when you mix water and ammonia, you get a kind of a new complex molecule. It's called, what is it called? Starts with A. The second word starts with H. Anybody remembers? Ammonium hydroxide. Ammonium hydroxide. Okay. Gas, liquid, gas. HF is very similar. It's called hydrofluoric acid, like hydrochloric acid. Okay. A similar molecule, I'm going to use the other molecule as for our example. Okay. The similar molecule to hydrofluoric acid is HCl, number 9 compound, hydrochloric acid. I'm going to ask you another question, and I'll try to keep my face as neutral and as innocent and naive as possible. Do I look naive and innocent? I probably never do. Okay. Hydrochloric acid. I can't keep a straight face. Is it a liquid or solid or gas? You have seen hydrochloric acid as a cleaning agent too, probably for bathroom cleaning. Don't put ammonium hydroxide and HCl together. It's not going to be fun. It's going to be extremely disastrous inside the bathroom. Okay. HCl, hydrochloric acid. Is it a solid or a liquid or a gas?
Liquid.
Liquid. T. Who are you, T? Trevor. Turn on your videos, please. I want to see the real people, not letters. It's no fun in looking at letters. That's why I'm a very hands-on. That's why when pandemic started in spring, I decided to teach using this technique. So this is it. You don't get a PowerPoint. So what we are learning here, the video and the still picture when I finish writing on the board, that's all your learning material is, along with the textbook. If you have any doubts or if you want to read the relevant materials in the real textbook, then you can reuse the real textbook. That's why I'm not so hung up on the edition of the real textbook. It doesn't have to be 13th edition. We are still kind of working on the solution manual. I didn't really find a good deal on it. Just reminding everyone right now. We are 1:34. We have about 11 more minutes. Okay, what do you guys think about HCl? One answer is it's a liquid. Is it a liquid? Is it a solid or is it a gas? It's not a liquid. HCl is also a gas. So what you see in the bottle, whether you're working in a research lab or you're working in a company that's using HCl, or you're using HCl to clean your bathroom, toilet bowl, or whatever, it's a gas in what? Something here.
Water.
Yes, Tatiana, water and HCl. So what you get as 12 normal HCl or 6 normal HCl or 1 normal HCl or half normal HCl, that's the strength of HCl. How many H you can get out of a certain amount of that solution? It's a solution. All right, we are talking about another chemistry term. Even though we are not really, we are taking some distracted paths like scenic routes. You're driving from San Francisco to Fresno along Pacific Coast Highway or 101. You just decided that you want to go through the scenic route. You're taking off like, oh, that looks like a nice, beach by Pacific Coast Highway. Let's get on PCH and check it out and then come back. So that's what we're doing. I just want our journey to be not boring. It's probably already pretty boring. My apology in advance if I'm a terrible instructor and if you're already beginning to hate me, that's okay. It's normal life. But then I'm trying on my best to make it as enjoyable as possible. So HCl is a gas. If you want pure HCl, you will have to get it in a cylinder. I don't really have anything that looks like or resembles a cylinder. You know, you have seen the propane tank, right? It's a big fat propane tank, like pretty big at this tall, right? I don't have my butane torch here. They're all in my research lab. It's like a propane tank. It's about that. The perimeter is about that big. So it's a small cylinder about this much, this tall, maybe 1.5 feet. The diameter will be maybe 4 or 5 inches. And then you have a regulator and then you have a hose. When you turn on the hose, gaseous, like HCl gas comes out of it. Sometimes you need that for research, and that's pure HCl, no liquid, no water in it. Whenever you see HCl in a solution, in a liquid form, it's not just HCl, it's HCl plus water. Okay, so we get that. So now the next discussion. So different elements cannot be broken down further and retain its elemental properties. Hydrogen has specific properties, helium has specific properties, boron, carbon, all the elements in the periodic table have their unique properties. That's why they're elements. Hydrogen is different from helium, lithium is different from beryllium, boron, carbon, nitrogen, oxygen, fluorine. That second row is done. Then you start the third row. Then you start the fourth row, so on and so forth. Then you have the transition metal elements. Okay, transition metals are elements. They are sometimes written in a different corner of the periodic table. So the whole idea is that when you guys finish this course and when we guys understand the periodic table, I'm not going to be asking you to memorize the periodic table. When you guys figure out like how the electrons, as you are going from hydrogen to helium to lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, as you are going up and up the chain, as you are filling up your hotel or motel with more and more people, you cannot just randomly throw people in different floors. Like I'm the first person, your motel is completely empty because you guys are doing some, the owner was doing some cleaning or renovation. I'm the first one, and if I say, I'm gonna go on top of the fourth floor in the balcony, in a real life scenario, I can probably do that, and I can probably buy it out by paying more money. In the elemental world, if I come with 1 proton and 1 electron, I have to go to the bottom of the chain to the level 1, room 1. 2 protons, 2 electrons, helium, that guy goes very close to where hydrogen lives. The next person, 3 electrons, 3 protons in the nucleus, lithium, gets to the 2nd floor. So on and so forth. So there are some certain rules. So the nucleus holds on to the protons, positively charged, and neutrons. The number of neutrons can change the property of that particular element, and they're called something else, isotopes. And the number of electrons, they are kind of like the planets, okay? The sun is the nucleus, and then the electrons are kind of forming a cloud, like a not 3-dimensional. I would rather say that it's 2-dimensional, but like a layer, like a sheet, okay? Like a balloon or like a bubble, soap bubble. But imagine there is a little nut in the middle, then you have a soap bubble, then you have another soap bubble, little bigger. They're concentric because their centers are all at the same place. Then you have another bubble, and as the number of electrons, as the element gets bigger and bigger, hydrogen is the tiniest element. Helium is the next bigger element. Lithium is the next bigger element. We don't put hydrogen, helium, lithium, beryllium, boron, carbon in a column, or we don't put all of them in a straight line. We put in a strange way, right? We put hydrogen here on column 1, helium here on the last column, and then we put lithium underneath hydrogen, then we put beryllium next to lithium, then we move boron here, then carbon, nitrogen, oxygen, fluorine, and neon under helium. We do that because their properties match. When you organize elements in a certain way, when you go down a column, the certain properties of those elements, okay? Hydrogen, lithium, sodium, so on and so forth, these properties are very similar. They have some common attributes. The next column, there are some common attributes, so on and so forth. Fluorine, chlorine, bromine, iodine, they all have very similar behavioral patterns. That's why they make HF, HCl, HBr, and HI. All 4 of them behave like strong acids. They all have very similar behavior. Fluorine gas, chlorine gas, bromine gas, iodine gas, they have very similar properties, so on and so forth. So Helium, neon, argon, krypton, xenon, they are like the celebrities of the periodic table or the world of elements. Periodic table is a combination or the house of elements, and they are located in certain corners of the periodic table depending upon the number of number of subatomic particles. So when you break down an element, you get the subatomic particles, and you basically we won't be dealing with neutrons too much because we're not going to be doing nuclear chemistry. I don't know much nuclear chemistry other than the fact that across our house, what are the odds of having two chemistry families living in the same neighborhood? Right across our house, not the opposite house, but one house next door, there is a retired nuclear scientist from UC Berkeley who is extremely religious right now. He's pretty old, and he lives there. Really nice, down-to-earth guy, and sometimes we talk about stuff, and I'm usually uncomfortable when he talks about his own research with the nuclear stuff like isotopes and gamma ray radiation and things like that. So when you mess with the nucleus, you can produce a lot of energy, you know, atom bombs and all that stuff. There, you're basically dealing with the nucleus. When you make one element into a different element or one isotope into the different isotope by destroying neutrons or by adding neutrons or blowing the nucleus with high energy gamma rays, you are really making a mess or a disaster, or using energy in a nuclear plant powering like a whole community or a whole city or multiple cities. Okay, so we won't be dealing with that. We will be primarily dealing with, in this course, we'll be primarily dealing with 144, primarily dealing with electrons. So what we're going to be doing is we're going to be stopping our discussion right now. Anything interesting in the chat? I sent the study guide here in the chat. That's very nice. So maybe you guys can copy, and before you jump into it and order it, just make sure that it's the right one. If you have any questions, you can run it by me. I'm going to check it too. So we're going to start talking about the breakdown of an element, of an atom, and see what's inside an atom. And then our job will be to basically figure out electronic configuration. If you look at the book, it'll talk about something like electronic configuration, you know, like what's inside an atom, an element, what is it made out of, proton, neutron, and elements and electrons. Our main job will be how do we organize the elements? I mean, sorry, misspoke. How do we organize the electrons? If I have one electron, that's all, like hydrogen, where do I put it? Two electrons, where do I put it? When I have three electrons, do all three electrons go in the same level, or I go to the next level? Things like that. Are there sub-levels? Like you may have a motel, level 1, level 2, level 3, level 4. Is level 1 only one bed in a room? Second level, are there only one type of rooms or two types of rooms? So the first type of room, how many people can sit there? How many electrons can go in there? How do the electrons go in there? They can have their spin. So do the spin, that both the electrons go in the same room with spin up, like head to head, or one person sleeps this way, other person sleeps that way, okay, so that the other guy cannot hear him snore as much as possible. What's the other type of rooms look like in that same floor? How many types of rooms can you have in that motel? Level 1, one type. Level 2, two types. Level 3, three types. Level 4, four types. Okay, we don't have to go beyond that. We won't even probably go to like level 3. We'll pretty much stay within level 1 and level 2, and deal with different types of, you know, configurations. So we're going to be learning all the nitty-gritty details about that. This sub shell levels are called orbitals. So we'll be learning about the shells, we'll be learning about the orbitals, and you will find out that in the world of organic chemistry or biochemistry, the most important electron or electrons are the ones that are almost at the outside of the whole deal. You may have shell 1, shell 2, and shell 3. You will find that if you're dealing with an element that has 3 shells, it's going to be the electrons in the shell 3, in the outermost shell. They're going to be most valuable and important for figuring out how this dude is going to bond with somebody else, what are its properties like, so on and so forth, okay? So we're going to continue our discussion. I'm going to post the video. I'm going to post the picture on Canvas. I'm also going to post a picture of a periodic table. I don't think I have done that for this class. And then we're going to meet on Thursday at the same time, and we're going to discuss, get into the element or the atom and start talking about real organic chemistry, okay? So pretty much done. I'm going to move the camera to the front of my surface, sit down on my desk. I can hang out for another 5 minutes. Oh, important. If anybody wants to meet with me during my office hours, I'm going to send you guys an announcement too. Please email me or send me a note, then I'm going to set up a Zoom meeting. The other day I had a Zoom office hour session for like an hour. Nobody showed up, so I'm not going to do that. Usually I don't get too many people during my office hours. If you have any questions or concerns, or you want to have a Zoom meet with me, 1 or 2 or 50 people, just let me know. I'll set up a Zoom conference, and then we'll go from there. Okay, I'm going to switch to the front camera. Any comments, guys? Otherwise, you can check out if you want. I know that the number has dropped significantly from 43 to 24. I can take any questions right now. Are you comfortable with this teaching style, or are you already like your blood pressure is going up? What do you guys think? You don't have to please me. I just want some feedback for adjusting myself. I'm not going to go back to PowerPoint. I'm not going to be using PowerPoint, so that's not going to happen. But something else. Any feedback is good. But again, I'm not trying to hear like good words. It's okay. Yeah.
I like it.
Yeah. And you are Holly. Okay. Holly is not going to make it this time. She'll have to come back. She already annoyed me. She's in my blacklist. I'm kidding, okay? Don't take things too seriously. That comes out of my mouth.
Do we have homework?
We have homework. I don't want to post it right now because sometimes when I post the homework too early, it unnecessarily increases your blood pressure. Like, oh my God, I don't know how to do that. I'm not going to do that until we cover like a decent amount of concept and materials in the class.
Okay.
Like
Thank you.
It's pretty good. Is that a lamp or just a flower or vase or something in the corner?
That's a lamp.
That's a lamp? That's a pretty cool
Yeah.
lamp. It brings back memories from like classic movies. That's very cool. If you burn your house down, right? It's not gonna. Your wall is far from that lamp, right? Oh, it's an electric.
Yeah.
No, not that. The thing on the wall. What's that?
Oh, that's a mason jar with flowers, and it has lights, but it's not going to burn down my wall.
Okay. Anybody else? Any other random comment? If you had a really good lunch, I don't want to hear about it. I'm very hungry right now. If you had a really trashy lunch, then it's a. If you say, Dr. Maitra, I went to Jack in the Box and had their 2 tacos for $1, then you can share it with me. Otherwise, you don't have to sit there. We don't have to stare at each other's faces. See you guys on Thursday, okay? Bye, have a good time, and be safe.